Good evening. Only a little while ago, the idea of landing a spacecraft on Saturn satellite Titan would have seemed fantastic, but that's what the Huygens probe has done. We'll be talking to Michel Doherty and John Zarnecki. But on that dramatic day, Chris Lintott joined the scientists, waiting to see what was going to happen.
Here at the European Space Agency's Operations Centre in Darmstadt, scientists are gathering to collect the results from almost 20 years' worth of effort. If all goes well, in a few hours the probe will begin its descent into Titan's mysterious atmosphere, and it's the last time in any of our lifetimes that we'll be landing on the surface of a solar system body without any idea what to expect. The largest of Saturn's moons, Titan is the only satellite in the solar system with a dense atmosphere. The thick haze has prevented a direct view of the surface, and all we have to go on so far are these images, taken using special filters by Huygens' mothership, Cassini. They reveal what appear to be surface features, but determining their nature needs a closer look. It's the end of a long journey for Huygens, and many of those arriving here today have been working on the project for 20 years.
You look at Saturn, it's almost like a solar system of its own, but then there's one very special object, and it is Titan. It's the biggest moon, but it's the only moon in our solar system with an atmosphere. That alone makes it important, but then when you look at the atmosphere, you see it's made of nitrogen, just like our own atmosphere. It's got nitrogen, hydrogen, carbon, nearly all of the ingredients.
But no oxygen.
But no oxygen. But it's a cooking pot.
As Huygens begins its descent through the atmosphere, a parachute should open, releasing the heat shield, and only then can the 6 onboard instruments begin to work, transmitting information on the composition and on the dynamics of the atmosphere back to Cassini. After a couple of hours, if all goes well, the probe will prepare for landing, either on solid ground, on slush, or even on liquid. The surface science package will analyse its surroundings, but the extreme cold will soon penetrate the batteries and the probe's short life will end. Only then can Cassini turn to face Earth and begin to transmit its precious data. A long 67 minutes later, the signal should reach mission control.
It is very exciting, but there's a little bit of trepidation at the moment. But I think it's really ramping up. The adrenaline's kicking in and everyone's just excited rather than nervous about it now. We can't really do anything, we're just waiting for the results.
Events have started here at Darmstadt, and Huygens, all being well, will have entered the upper atmosphere 10 minutes ago. Now, although we won't get data back by Cassini for many hours, we've got 2 chances to eavesdrop. Firstly, optical telescopes are looking for the fireball that will accompany its descent into the dense upper atmosphere. And secondly, radio telescopes will be listening, trying to catch that signal aimed at Cassini, but we might be able to detect it from the ground. Huygens was never designed to transmit data all the way back to Earth. Conserving its battery power is all important. And we're waiting now for news from the radio astronomers, hoping for the first reassurance that everything is going according to plan. So Huygens is in the final stages of its descent, but we've got some exciting news.
Yeah, we really got some exciting news. I mean, we have been hearing a very faint signal from Huygens through the largest radio telescope in the States. So we can clearly identify this as the fact that Huygens is transmitting. So we can't say what it tells us, but at least we know that it's transmitting. So the entry has occurred properly, and Huygens is descending on the parachute.
So the parachutes are deployed, the heat shield has gone, and everything is working.
Yes, of course, we still have to wait for the last parachute to deploy for the rest of the descent, but we know we are on the parachute, so this is really good news.
I'm in the control room as Huygens makes its final descent through the last stages of the atmosphere. The heat shield is long gone and all the instruments are now working, taking data on the physics and chemistry of the atmosphere. And so we're nearly at landing already.
Yes, according to our calculations, and of course there are many different calculations, I think we're about 17 minutes away from landing right now.
And that will depend on the weather at Titan as well as many other factors.
Yes, the weather, it depends on the topography of the surface. You know, it depends on whether we land on the top of a mountain or at the bottom of a valley or what. But, you know, we're coming up for that point.
Well, obviously we can't look at Huygens itself, but this is about as close as we can get. What are we standing in front of?
Well, this is what is called the engineering model. It's representative in most ways in terms of the dimensions of the real probe.
Of course, your instrument is missing.
It should sit just about there.
And that's the surface science package.
The surface science package.
Right now, in the atmosphere of Titan, it's taking data.
It's taking measurements indeed. Even in the atmosphere, for example, we're measuring the speed of sound in the atmosphere. Now, the speed of sound is very sensitive to the composition of the gas. So we're, amongst other things, we're measuring the composition. We have motion sensors, so if the probe is being buffeted by winds, we shall also be sensing that. And we have a sonar, and if that works, that will tell us something about the roughness of the surface. We get a very different echo if it is very flat or if it's a very rough surface.
So Mark, in 2.5 hours we'll know whether your instrument's switched on, but what's the news so far?
Well, I've actually just found out that the probe's been on the surface for at least 45 minutes and it's still transmitting. It's still a radio link, it's still alive. So I'm just praying I get that science data.
I'm sure it doesn't matter at the minute, but how do you know that? How can you tell the probe's on the surface?
They've basically been detecting the radio signal directly with some of the large radio telescopes on the ground, initially Green Bank, 110 metres. We've been tracking that over the last few hours. It's gone over to Australia now at the Park Station, and they're following that signal, and we actually have seen it hit the surface and let the signal level out, so we know it's on the surface.
And so you're saying that's 45 minutes. That's almost already longer than was expected.
Sure. When I first started on the mission 13 years ago, 3 minutes was the maximum from the surface, and it's kind of going crazy at the moment.
Well, we've just heard that the probe's been on the surface now for 45 minutes and still transmitting.
Oh,
You hadn't heard. You hadn't heard that.
I've been. Oh, that's fantastic. Thanks, Chris. That's the best news I've heard yet, but I hope I'm going to get some more.
That's right. Well, still going, and we've just been talking, and they said when they designed the experiments, they were told 3 minutes on the surface and no more.
Yeah, well, as long as they don't come back asking for more money.
And it's only getting more tense here. We're still waiting for news from Mission Control. We haven't had any news of the first playback of the data. There are 4 playbacks. Cassini will repeat itself 4 times. But as yet, we've still got no scientific data from Huygens. And there it is! And indeed it is. You can see Mission Control celebrating, and that's the start of the real science from Huygens. Cassini is playing back all the information collected during Huygens' descent, and now we wait to find out the secrets of Titan's atmosphere. The end of a long, intense day, yet scientific work on the data had just begun in earnest. Then, just as we were heading home, the scientists joined the press in the canteen to share the first results and spectacular images of the landing site.
We have seen the impact of the probe with the surface directly from 2 sensors. We also have a sonar, and in the signature of that instrument, in the last few seconds or tens of seconds, we see a reflection off the surface, and we see that return getting closer and closer to us.
Thank you very much, and congratulations again.
It's obviously very early days. We've literally had the data for minutes, but we can see definitely the impact with the surface. We see that from 2 sensors and an indication of it from the 3rd. I think I can reveal now it's pretty close that we haven't splashed down. I'm not sure what we've hit, but it's something softish. We've got an impact deceleration of about 15 G. So it's that could be equivalent to, I'm not saying the surface is snow, but it's the sort of thing you'd get into deceleration you get in semi-compacted snow.
We have got a fantastic data set, fantastic images, and the few images that we have been seeing are just great. And also, the other instruments have been receiving some excellent data. So I think it's going to be a long night for the scientists to try to make sense out of this data set. So,
Especially as Huygens survived for a lot longer than I think anyone would have bet.
yeah, I would have never bet that Huygens would survive more than 1 hour on the surface. So this is really fantastic. And the data set which was returned from the surface is very good.
I know I'm blown away. I have yet to hear anyone else who doesn't feel the same way. That tells me there's going to be controversies, there's going to be fights, people are going to be analyzing over and over again. So, what a day.
Well, congratulations. I have to say, you expected 3 minutes when you began this project. How does 70 feel?
Absolutely crazy. 3 minutes was our wildest dreams only a few years ago, and only the new mission meant we could get longer, but 70 minutes is just incredible. Shame it wasn't on a liquid surface though, making oceanography measurements.
Especially as we now think there was liquid there and liquid nearby as well.
Yes.
It's nearly midnight. It's the end of a fascinating, somewhat chaotic, always exciting day. And for me, I'll always remember seeing those first pictures of Titan's surface, a moment in space program history to rank with seeing the far side of the moon or the surface of Mars for the first time. It's been absolutely incredible, and it's been a success.
Well, it was an incredible day. Welcome now to Michel Doherty and John Zarnecki. Well, John, what did Titan look like?
Patrick, it's a fascinating place. We're already seeing features, processes, which actually look rather familiar to us here on Earth. We're seeing hills, we're seeing features that look rather like runoff channels, features that look like shorelines, even fog, pebbles, things that look like small stones, and overall, superficially, those are quite familiar.
But very different substances.
Absolutely. What I call pebbles or stones are of course not made of stony material, but ice, probably water ice with a bit of hydrocarbon ice mixed in as well. And the liquid that almost certainly causes the channels and has rounded the pebbles is not water,
No.
but is liquid methane, almost certainly. So it's familiar processes, familiar features, but with quite alien materials.
And it rains on Titan, but it's not water rain, it's methane rain.
That's right. And in fact, I think that we've even seen definite chemical signatures of this methane rain. Because about 10 minutes after landing, the mass spectrometer, that's the chemical laboratory on board Huygens, detected a sudden increase of methane, about 30% jump. Now, what we think that is that methane rain has soaked into the surface. It's probably, wetted the surface just below where we've landed. And the warmth from the Huygens probe, because it's warmer than the surface, which is about minus 180 degrees centigrade, this heat has percolated into the surface and has probably evaporated some of the liquid methane. And this gas then has percolated up into the probe and been detected by the mass spectrometer.
There's a great deal of methane, but where did it come from? Do we know?
We don't. That's one of the things that we really need to try and understand, is that this methane is being generated all the time. If it wasn't, it would have disappeared out of the atmosphere. And so that's one of the really large outstanding questions that we need to understand. We cannot understand the atmosphere or the surface of Titan until we understand where this actual methane is coming from. And hopefully that will be one of the questions that the instruments on the Huygens probe are going to be able to answer.
At least the surface was firm enough to bear the weight of the spacecraft.
Yes, that's right. We in fact measured with the impact for the fraction of a second before the probe struck the surface. Then one of our instruments,
Yes.
and this is the first prototype of that instrument that we made in the lab. It's really a stick that is instrumented, and it protrudes through the front of the probe, and it has a sensor at the front that measures the force of the impact. Now, as this drove into the surface, and before the probe, which is 300 kilograms, before that hit the surface, so just for a fraction of a second, we got a very clean signal as this went into the surface. And it seems to indicate a material which has the consistency, has the mechanical properties of sand or clay. I'm not saying that that's what the material is, of course, but it gives you an idea of the consistency. I'm thinking of it at the moment as made up of small ice particles, so sort of the ice equivalent of sand. And this gives us the signal that we detected. We see just for a tiny instant, just as we hit the surface, a higher signal, a higher force. And there are two possibilities for that we can think of. Either there's a very, very thin crust on the surface. That could be a dry crust. It could be some of this organic stuff which is raining down, and that could give a crust. Or it actually could be that we hit with our sensor one of these pebbles that we see. So we could have hit it, pushed it out of the way, and then driven into the icy sand underneath.
Yes. Organic material. People are going to say, life? No, I fear not.
No. Organic material is what you need ultimately for life. But what we're talking about is relatively simple molecules made of carbon and hydrogen. But this is the start of the chain, the process, which under different conditions, as on Earth, ultimately led to the development of primitive life. Now, this won't happen on Titan, of course. It's much too cold, there's no liquid water, and very little free oxygen. So the conditions are not quite right, but the very basic building blocks are there.
Well, before Huygens, when Cassini was imaging Titan, a large area there called Xanadu. Now, I wonder, can that be a chemical ocean, do you think?
From the observations from Cassini, there didn't seem to be any signs of any type of liquid on the surface. And so we did image Xanadu, and so I don't think that that is made up of an ocean. But we've only seen a very small fraction of the surface. The observations from Huygens seem to imply that if there isn't liquid there now, there was quite recently in the past. And so that's one of the things that we need to try and do with the upcoming Cassini orbits. We have another 41 flybys of Titan. And so what we really want to do is image different regions of the surface, see whether we can look back at the probe site and try and get a better understanding about what's there. But really what Huygens data is doing for us is it's giving us the ground truth. We were able to take data on the ground, and we're now going to be able to stand back from Titan and try and get a better understanding of it now as well.
I'm going to slightly disagree with you, if I may. You said the observations didn't show signs of liquid. I think it depends on how you interpret them. They didn't see a glint, did they, of a reflection off, if you like, a glassy surface of liquid. But supposing that liquid were covered with this dark material, you know, this sort of scum floating on it, wouldn't that give a slightly different signature?
Yes, it certainly would. You wouldn't get that reflectance that you would expect from an ordinary liquid.
Well, the story really began on Christmas Day, when Huygens was released from Cassini.
In fact, this picture here shows you the final view that Cassini had of Huygens. It's a bit blurred, but it shows you the view that the camera had as the Huygens probe moved away from the main spacecraft. But in addition to that, my instrument was taking data during that time, and it was able to measure the magnetic field of the probe. And as the probe moved away, it was revolving around as it moved away, and we were able to tell how that field changed as the probe moved, and that then allowed us to work out the speed that the probe was actually travelling. And we were then able to tell that it had been released properly and that it would arrive at the top of the atmosphere on the 14th of January.
We know that Titan moves in and out of Saturn's magnetosphere. Does that have any effect on Titan itself?
Well, I think there are two different ways in which it's going to have an effect, and we don't know what that effect is. That's why we want to try and measure Titan both in and out of the magnetosphere. But the magnetic field in the vicinity of Titan is going to change. If we're out in the solar wind, we're measuring the magnetic field due to the solar wind. If we're inside the magnetosphere, Titan is seeing the magnetic field of Saturn. And these are two very different fields, and they're going to have an effect on the upper atmosphere of Titan. And so that's why it was so important for us to understand or to know where Titan was when the Huygens probe travelled down through the atmosphere. And as the animation is showing, you can see the magnetopore's boundary, the boundary that separates the solar wind from the magnetosphere, moving in and out as the solar wind changes. And so that's what we were able to do while the Huygens probe was travelling down through the atmosphere of Titan, was to show that Titan was actually inside the magnetosphere.
Well, the journey down through the atmosphere took Huygens 2.5 hours, and I've been fascinated by those sounds we recorded.
Yes, there was a microphone on board, a very simple microphone. I don't think we could call it hi-fi, but it gave some impression of the sounds of Titan as Huygens descended through it. And in fact, what we hear is essentially a rushing noise. There are not too many features in it. I like to think of it as the atmosphere, the air rushing through the rigging of Huygens as it descends. But it gives an impression of, you know, the substantial atmosphere and of the turbulence in the atmosphere, which actually surprised us. That the ride that we got, at least for part of the descent, was much rougher than we had expected. We had the main parachute, which is a very large parachute, 8 meters in diameter, and that was deployed for about 15 minutes. When we were under that, it was fairly calm. And then we moved on to a stabilizer chute, and it was then when Huygens was more subject to the local environment. The chute was much smaller, and we seem to have had some quite dramatic swings of the probe. If I can use this rather sophisticated prop,
The answer is a lemon, of course.
it is indeed, and this represents the sort of the support harness from Huygens up to the parachute. We were seeing swings of probably at some point 60 degrees, and it was so severe that the radio link from Huygens back to Cassini momentarily dropped. We didn't lose it, but the strength of the signal went down. This is a graph from one of our tilt sensors, and you can see here that the probe really was, as one of my colleagues put it, rocking and rolling. And then as we came through the cloud deck at about, or maybe 25 kilometres, the trace drops and we move into a region that is much calmer, much smoother, and in fact it's like that all the way to the surface. You can see when we hit the surface, the trace is then rock steady. So that is one of the many indications, of course, that we were not sitting on a liquid. If we were on a liquid, we'd of course expect to see some further motion of the probe.
Bear in mind that on the way down, Huygens was by no means idle, but making measurements all through the descent.
Indeed, there were many, many measurements that were made. One of the key measurements during the descent was an analysis of the aerosols, these sort of pesky particles which prevent us from seeing the surface of Titan from the ground or from above the atmosphere. Now, the instrument is called the aerosol collector and pyrolyzer, and you can get an idea of how it works in this animation. It puts out essentially a filter paper. It protrudes just beyond the front of the probe, and a motor sucks in some of the atmosphere through the filter paper. Then the filter paper is pulled in and it's put into an oven and heated up to about 600 degrees centigrade. So that will vaporize the aerosol particles. And then a gas blows the resultant vapor into the mass spectrometer. It's a complicated business to analyze the data, but they're working on that right now.
All this was done something like 900 million miles away, and all purely automatic.
It's unbelievable, isn't it? And we mustn't forget what a technological achievement this has been.
Huygens lasted for longer than anyone expected, but when Cassini went out of range, that wasn't the end of things, was it?
No, this is one of the most remarkable aspects, I think, of the whole project. We had, in our science team meetings early in the project, I remember we talked about that, could ground-based radio telescopes pick up the signal from Huygens directly? And it was regarded as science fiction, completely impossible. But the technology has come on so amazingly in the last few years that for, I think, the last 2 years, the European Space Agency and the radio astronomers have been working together to see if indeed they could pick up the Huygens signal directly.
And they did.
And amazingly, we know for certain that Green Bank in the US and Parkes in Australia picked up the carrier signal from Huygens. That's like the ringing tone. Doesn't have the data on it. But it came through, in fact, loud and clear. We can see on this plot here the signal from Huygens as received by Green Bank. And in fact, it was very easy to pick up in the end. It was remarkable. And they, in fact, tracked the signal from Huygens for several hours. We don't yet know how long for certain because Huygens set below the horizons viewed from Green Bank. So the other telescopes are going through the data. But it looks as if Huygens was transmitting for a total of at least 6 hours, meaning there was more than 2 hours on the surface. Quite remarkable.
Almost everything worked. There was just one communication channel that didn't, but the information there had been collected from the ground.
There was a small failure. One of the receivers on Cassini failed to pick up the data from Huygens. But remarkably, the science that has been lost with the loss of that channel, that is mostly in the Doppler wind experiment. That is an experiment which was planning to measure in great detail the wind profile through Titan's atmosphere. But it seems with this remarkable set of detections by ground-based radio telescopes of the carrier signal, that's like the ringing tone from Huygens directly on the Earth, it seems, and in fact we've just heard in the last few days from the Doppler wind experiment team, that they've been able to analyse that signal. They've been able to pick out the minute changes in frequency, the changes in hum, if you like, the tone of that signal, and they can interpret that in terms of a wind profile on Titan as the Huygens probe descended. So it seems that, in fact, the science that has been lost from that technical problem has been recovered in a somewhat unexpected way.
Well, we've got the data now. They're going to be analysed. And what do you think is going to happen next in the analysis? What do you hope to find, Michelle?
I hope to get a better understanding about what we're actually seeing on the surface. We assume there's liquid there. It would be nice to get a better understanding about what type it is, but also get a better understanding of the global morphology of the region. I mean, one of the images that I really loved was about 8 kilometers above the surface,
Yes.
where you saw what looked like a range of hills
Yes.
and a shoreline.
Yeah.
And on this range of hills, you can see these channels which seem to be leading down to a shore. It was almost like looking at the cliffs of Cornwall.
Yes, indeed.
And so I really want to get a better understanding about the type of morphology that we're seeing and try and get a better understanding about what type of surface we're actually seeing.
You're still hoping for an ocean, aren't you?
Yes, I am.
So am I.
Maybe there isn't an ocean there. Let's call it a very large lake.
Yes.
I still think it's there, perhaps hiding. And of course, that'll be right for the next mission, you know. I think we can now... I'd like to send a balloon to Titan, I think, you know. It's the atmosphere is ideal to send a balloon right around Titan. I think it would take about 2 weeks. You could survey the whole surface, you could identify the really interesting regions, and then you could bring your balloon down, maybe siphon up some of the liquid, do the analysis on board, maybe a little bit...
What I'd really like is to have an orbiter. I'd like a spacecraft to spend 2 or 3 months
Yes, indeed.
orbiting just above the surface, so that we can image the entire surface, but we can take observations of the plasma too, so we can get a
Have
much
either of you any idea when we will get another Titan probe of any kind? Any ideas at all?
The trouble is there's so many exciting things to do in our solar system.
Exactly.
You know, Europa is crying out for a
Yes,
visit,
indeed.
isn't it? You know, another wonderful place. We're spoilt with riches here. I would like to think that within... Well, I think the programme is pretty well tied up for the next 10 years. But I think in the time frame 2015, 2025, which the European Space Agency is now studying, I think we have a chance. Probably, again, an international collaboration, which, you know, we have to say worked wonderfully in this case.
And I think as we begin to understand the Huygens data better, as we start having more and more close flybys of Titan with the Cassini spacecraft, we're going to find out there are even more questions that we don't have answers to. And so I think we're really going to want to go back again and again.
Well, Michelle, John, thank you very much. Well, Saturn's been nicely placed in the sky, and also we've had a comet, Comet Matchels. Not a Hale-Bopp by any means, but still quite a nice comet. This lovely photograph by Martin Mobley shows a tail. Also, the comet passed quite near the star cluster for the Pleiades. That was a lovely sight. Also, the Deep Impact probe being launched. That will encounter yet another comet, Tempel 1. Well, comets may come from the outer part of the solar system, where we find the Kuiper Belt. It's the Kuiper Belt I'll be discussing when I come back next month. So until then, good night.